Another important application of the dot product is that it gives us an algebraic method for determining whether two vectors are orthogonal or perpendicular. So remember our formula, so we know that the cosine of the angle theta between two vectors A and B is equal to A dotted with B over the length of A times the length of B. So if two vectors are orthogonal or perpendicular, that means the angle between them is going to be pi over 2, or 90 degrees. And we know that the cosine of pi over 2 is equal to 0, so two vectors are orthogonal or perpendicular if the cosine of the angle between them is 0. We know that cosine of theta is A dotted with B over the length of A, length of B, so if the cosine of theta is 0, that means that A dotted with B, or the numerator of this fraction, is equal to 0. So two vectors are orthogonal or perpendicular if and only if their dot product is equal to 0. So as an example, we know that the vectors 1, 2, 3, and -2, -5, 4. So these vectors are orthogonal because if we do their dot product, so if we compute their dot product, we get 1, 2, 3 dotted with -2, -5, 4. So this gives us 1 times -2 is -2, 2 times -5 is -10, so -10, and then 3 times 4 is 12, so plus 3 plus 12, so we get -12 plus 12, which is equal to 0. So the dot product of these two vectors is equal to 0, which tells us that these two vectors are orthogonal. And since these are two vectors in 3 dimensions, it would be difficult to know this just by visualizing it. So the important thing here is that the dot product gives us a way to check if two vectors are orthogonal. So orthogonal is equivalent to the dot product being equal to 0.